Welcome to Sparkle Project. This is Lesson 6 on Variable Rate Technology and the topic on Variable Rate Seeding. I'm Natalia Hernandez Sánchez from the Universidad Politecnica de Madrid in Spain. This presentation is focused on the specific metering driving used for variable rate seeding. The variable rate application has evolved from a ground wheel drive to a motor drive system that operates directly and individually on its seed metering unit. A major advantage is that with no ground drive wheel, under application due to slippage is avoided. The three typical seeders are conventional seed drills, pneumatic seed drills, and precision air seeders. All of them can be adapted to variable rate seeding. For conventional driving, a ground drive wheel can be found connected through a drive chain to the metering drive shaft. A gearbox changes the ratio between the angular velocity of the wheel and the angular velocity of the shaft. Thus, the kilograms of seeds per meter, or the number of seeds per meter, is adjusted to reach the desired application rate. Pictures illustrate some examples of the mechanical elements included in conventional metering driving for volumetric system. It is worth it to note that a single shaft drives all the rollers. For disc metering systems, the same elements are mounted, and again, all the discs are driven by the same shaft. As previously indicated, for variable rate application, the drive system operates directly on the seed metering unit. When hydraulic motor is used, it usually drives the metering shaft. Therefore, some disadvantages still remain, such as maintenance of chains and bearings, vibration induced into the meter from chains, bearings, and sprockets, and lack of hydraulic systems. In contrast, the electric motor is installed directly on the meter system. No chains and bearings are included. Vibration is reduced, and the response is faster. In these pictures, we can see the combination of mechanical and hydraulic elements. Indeed, hydraulic solutions are usually applied to convert ground-driven drills to hydraulic drive variable rate. This is an example of an electric motor drive. V-drive is a 12-volt electric drive. The motor is mounted directly on its meter housing and drives the seed disc by pinions. V-drive removes high-maintenance items such as chains, sprockets, and head shafts from the planter, while also eliminating the need for row clutches and hydraulic drives. Individual control on each row allows high accuracy in providing the application rate according to the specific zones established by the prescription map, as the figure illustrates. Shear drive is another example of an electric motor. Shear drive includes cold-forged, high-grade steel gears, precision bearings, and a drive chain, all submerged in a full synthetic fluid bath inside a sealed unit to minimize maintenance. This slide shows two examples of the capabilities that the individual control of the seed meters offers. During turn compensation, meter speed is increased toward the outside of the curve and decreased toward the inside of the curve in order to maintain consistent input rates for all the rows. On the left side, we can see the screen visualizing the turn compensation. The bar chart includes a meter speed reference line, 100%, and shows higher speed, that is, higher bars, for the outer rows and lower bars for the inner rows. Moreover, as we can see on the right side, individual control allows setting different seeding rates between rows, in this case for seed core male and female rows. Finally, a power generation unit is needed to power the electric motors. Here we can see two options: an onboard hydraulic power generator that utilizes power beyond, and a power takeoff power generation unit. The main advantage of this system is that frees up hydraulic capacity on the tractor, as the PTO powers the generator. And that's all for now. Thanks for your attention.